Now we're going to look at our next couple of examples so we can see more about the meaning of function notation and how we are to interpret that. So example 4 says that you have 7 quarts of paint to paint the trim in your house. A quart of paint covers 100 square feet, and the function A of Q equals 100Q represents the area in square feet that Q quarts of paint cover. It's asking what domain and range are reasonable for the function. So we need to think about all of our possibilities for what we could use for domain and range. Now remember, domain is your input. Those are your x values. Now in this case, we don't have x values because we're not using the letter x. If you feel more comfortable with using the letter x, you can go ahead and change it. That's perfectly fine. But that's our input. Okay, those are our, in this case, it's going to be our Q, which is the number of quarts of paint that we are using. So let's think of some possibilities for this. Could you use a negative amount of paint when you're painting? No, that's not possible. You're not taking the paint off the wall and putting it back into the container. So we're not going to use any negative numbers. Negative numbers are not reasonable. Okay, so now let's look at 0. Could you use 0 quarts of paint? Well, yeah, you could. You're not going to get anything done, but you could use 0 quarts of paint. So 0 is a possibility. Oops, I say is possible. Okay, so now let's look at our positive numbers. Okay, we could use 1 quart of paint, we could use 2 quarts of paint, and we could keep on counting. We have to think about where we are going to stop, though. And in this case, if you look back at the problem, it says in here that you only have 7 quarts of paint. So you can use up to that 7 quarts. You can't use more than that because you don't have any more than that. So 7 is your greatest number possible. So that means that we can use any number of quarts of paint, starting with the number 0, going all the way up to the number 7, including both of those. Now, again, remember, if you use 0, you're not going to get anything done. So you probably don't want to use that, but it is a possibility. 7 is the greatest possible. Now, if we are actually going to be painting, though, we can't actually use the number 0. So we're going to say that 0 is not equal to it. But 7, we can use all 7 quarts that we have. So this one, it can be equal to. So when we write our domain, we're going to use our inequalities that we were talking about last week. And we're going to say that we can have 0 less than, instead of x, we're going to use q. And then it can be less than or equal to 7. So that's our domain. So all of our x values have, so all of our x values, or our q values in this case, our input, needs to be between the numbers 0 and 7. Now, we are using the inequality notation on this one because this would be a continuous function because of the fact that you can use partial quarts of paint. You can use only 2.5 quarts of paint or 2 1/4 or 2 1/8. That is possible. So that's why we need to use our inequality notation on this one. So now let's look at our possibilities for our range. Now our range is the actual area in square feet that we're going to be covering with the paint. So remember, our range is dependent. That is going to be dependent on how many quarts of paint we use. So this is our output. In this case, our output is being represented by A of Q, this is our function A of the variable Q, of the independent variable Q. And this is the amount of area that we are going to be able to paint. Again, this is dependent on what our x values are. So in order to find out what our y values can be, or our range can be, we're going to have to go back and look at that domain and only use those numbers. So for our range, we're going to use our equation, which is A of Q is equal to 100 times Q. And what we're going to do is we're going to take those possibilities from our domain and plug them into this equation. Now, since we can be using any amount between 0 and 7, 0 and 7 are the numbers that we're going to plug in. Now, of course, if we use 0 quarts of paint, that means that we're not going to get any painting done. So our range is going to start with 0 because A of 0 equals 100 times 0, which is 0. So our range is going to start at 0. And we're not going to include that because we don't want to paint nothing. We do want to paint something on this. And then we're going to go look at what the maximum amount can be. So our maximum amount is going to be A of 7, because that's the most amount of paint that we could possibly use. So 100 times the 7 quarts of paint that we could possibly use is going to be 700 possible square feet that we can do. So our range is going to be from 0 is less than our function, A of Q, which is less than or equal to 700 square feet, which is the maximum that we can go to. Now this problem is a little bit different because you have to use a little common sense and think about what is possible on this. So you're not just using what's in the problem, you're using what you know outside of the problem, such as the fact that you can't have any negative numbers in your domain for this one. You can't have a negative amount of paint that you use. And then, of course, you have to keep in mind, use a little common sense, you can't paint more than what you have. So when we're finding out our range, we have to use those numbers from our domain. Also, keep in mind that since we said that our function notation is the same thing as saying y equals, you can also write this as 0 is less than y is less than or equal to 700. That is the exact same thing. So now we're going to look at example number 5 on our notes. And this is giving us a table that we're making. Now it has an extra column in this table because it also is including in what our function is. So that way we can figure out what our output is based on that function. So we're going to start with our x value of -1. Now notice how our domain, we're using specific numbers. We're using the -1, 0, 1, and +2. Those are the only ones that we're going to be plugging in. So I'm going to take the function that we have, so f of, and then since we're plugging in that -1, that's our domain that we're using for our first problem, equals -3 times that x value, -1, and then we're going to add 2. Oops. And when we work that one through, -3 times 1 is a +3. 3 plus 2 gives us an output, or a range, of 5. So when our input is -1, our output is 5. And we're going to follow through on that with each of the following problems. So when we go to our input of 0, we're going to plug in 0 for our x value. So we come up with the function of 0, f of 0, equals -3 times 0 plus 2. When we do -3 times 0, we get 0, and 0 plus 2 gives us 2 for our y value, for our output. So our next input that we have is 1. This is a +1 this time, so I'm going to plug in a +1 for our x value. So f of +1 is equal to -3 times 1 plus 2. -3 times 1 gives us -3, and -3 plus 2 is going to be -1. So when our input is a +1, our output becomes -1. Now our last input is 2, +2, so we're going to plug that in. So our function, when our x value is 2, f of 2, is equal to -3 times 2 plus 2. Now I want to point out here, remember, this f of 2, that's not another number that you're including in your calculations. That's not another variable. That is the exact same thing as saying y is equal to negative 3 times 2 plus 2. So don't forget that is f of 2 is one thing all by itself. It's not something else that you're adding in. You're just saying specifically we're looking at our function when x is 2. And when we do that, we multiply negative 3 times 2 to get negative 6. Negative 6 plus 2 is going to give us negative 4 for our output. Now our question says to find f of 1. Well, this is saying find our function. What is our function valued at when our x is equal to 1? Well, we found that out over here already on our table. When x is equal to positive 1, our y value is negative 1. So f of 1 is equal to negative 1.